Yeah, so I'm going to be talking about a field that is one in which I'm I've been working in for the last couple of years. And I'm based normally at the Institute of Zoology, but some of the places we're going are all over the world. The topic specifically I'll be covering is regarding marine protected areas and illegal fishing. I'll touch briefly upon some of the work that Anna was talking on regarding the social dimensions of these fisheries and why we should care. And then I'll talk about what I consider the main meat of this, which is regarding the opportunities for research and scientific monitoring around surveillance. So these reserves require increasingly surveillance and enforcement, but we should be piggybacking on that and to do our monitoring. Specific technology I'll be talking about is hydrophones, which are used for vessel detections. Drones, everyone knows about drones, everyone loves them, but they do present some challenges. And the opportunities these technologies afford us around habitat mapping, megafauna, and how some of the analytic tools we can bear to sort of help improve our abundance estimates. And finally, I'll talk about the subject of patrol-based monitoring. This is an emergent field, and I'm hopefully by the end I'll have you convinced that it's an important one. So Jessica touched upon this. So I've worked with Jessica for 6-7 years now. Jesus. And one of the things that we started off by doing was to look at the biogeography, so the change in abundance over large spatial scales for sharks. And one of the sort of key outcomes we saw was that proximity to market across the Indo-Pacific, Jessica was talking about Western Australia, across the Indo-Pacific actually is the biggest signal when it comes to predicting the abundance and distribution of sharks. So that doesn't leave much room for refuges, and we found them that if you can look at these two broken sticks models there, you see that our refuges are 1,200 kilometers away from human markets. So there's not much ocean left, really. And it's also limited, the strong hotspots are when the seabed is shallower than 500 meters. So think about this, 1,200 kilometers away from market and shallower than 500 meters. On a global scale, there's not much. We also saw that the elevated regions of sharks were due to the remoteness from human markets, not because of the special protection afforded to them in some cases. So really, there was a need that we saw for better IUU enforcement. One of the first places I went to when I started working on this subject 7 years ago was the British Indian Ocean Territory, or the Chagos Archipelago. And this was the first sharks I ever got the chance to see. This was a confiscated catch from one of the illegal fishing boats that Anna was mentioning, that traveled all the way from Sri Lanka just to target these species. And this is a picture taken by our PhD student, Claire Collins, from the market in Sri Lanka. So that gives you an idea of potential connections between the two. And she's been, again, that Anna touched upon was that she's been doing a lot of work trying to map out the various drivers and the various motivators for these fishers to go this way. And there's obviously both the drivers for fishing sharks, and then there's the drivers for fishing illegally, and the two need to be considered separately, but also sometimes overlap. But one of the drivers, which I want to highlight, is the perception of risk. And on average, the fishers, if you ask them, will think that the probability of being caught is between 5 to 10%. So that doesn't really disincentivize them that much. So we've been working, trying to come up with ways that we can improve the surveillance of the reserve And this is obviously one component, part of a bigger project trying to modify behavior. We've been deploying these passive acoustic hydrophones on the seabed. And we've been working with industry partners here because the technology is quite, takes a lot of investment in terms of R&D. And the way the hydrophone works is that you deploy them on the sea floor, and they can yield instantaneous vessel detection, and then can also monitor biological activity in the same process, because most biological activity gives off noise. The other component we'll be looking at is drones. And you know that they come in range and sizes, and some of the cheapest ones, you can go to one of the local tech stores and pick it up, and it'll be about 100 quid, or you can spend $500,000 if you want to. And the bigger ones require an entire team of pilots and technicians, in which case, from a sort of practicality point of view, you might as well have a plane. So some of the smaller drones are not outside the technical ability of most fishery patrol officers or marine reserve rangers. It does require some training, and increasingly, especially over the last couple of years, legislations and regulation around drones has been catching up massively, and we're finding that increasingly prohibitive. So what we did with the hydrophone is, this is what it looks like. So it's quite a big unit. And it was deployed about 30 meters inside the lagoon. And it was left there for 6 months. So 6 months, with the patrol boat coming in and being in the area and then leaving again. And we were looking specifically here, what are the sort of biological indices we could tease out from the acoustic signal. See if I can get the video to work. There it is. Just press the red one. No. Oh well. Anyway, it was just a video showing you the actual deployment itself. And this is a long-term the spectrogram for the entire 6 months of data. So already you can start teasing out some of these biological patterns, related to seasonality. And what we looked at was the mean noise values. So, how much noise is actually occurring. What's the acoustic complexity of the noise? And this is quite strongly correlated with diversity indices if you look at it across biogeographical scale. And one of the things we saw was that there was both a strong seasonal and ideal patterns. And here you have these boxes denotes the monsoon season, and here you have average across a 24-hour cycle. So you can see that there's both a strong seasonal cycle and a strong daily cycle. And we also looked at the number of dolphin detections within the area. And this is pretty much the only information we have on these species. There's been no dedicated survey looking at cetaceans there just yet. And again, we saw very strong both seasonal and diurnal signal. Interestingly, we saw very little vocalization during nighttime. And there's potential different interpretations of this. What we do know is that some of the sharks which have been tagged tend to leave the lagoon during the night. And it could be related to this. It could just be related to lack of socialization during the night or lack of foraging activity. We don't know yet. Some of the work that we've been doing on the drones, we've been running these trials in Biot, in Chagos, and also in Belize. And we also had the opportunity to survey some, when we were in Biot, we compared pristine islands and rat-infested islands, or islands that were all coconut plantations. And we basically did circumnavigations of the islands and did some surveys across the foliage to get sort of tree cover. And we've been also trying to get these drones integrated with the patrol-based monitoring that's ongoing. So this, you can see the video here. This is my student Melissa, who's doing her PhD on these. You know, so it's quite easy to deploy. That was the work that I do, whereas Melissa, she requires it's quite a lot of training needed to actually pilot these things. So she's been doing, she's a commercially qualified pilot, and we have an operations manual, obviously, in order to comply with regulations. But as I said, this is changing fast. This is Melissa and Sophia in Belize, and typically a team of 2 people, which have been trained up, can deploy these. So these are some of the patterns we got between the pristine and the old plantation islands. So there's some evidence from previous work that the bird colonies, which are on the pristine islands, are actually subsidizing the adjacent reefs. And we wanted to see if we could add a little bit to that story and maybe survey the megafauna. So we know that fish biomass and coral reef production is enhanced. We don't know what's happening for larger animals like rays and sharks. And what we saw was that, of course, you know, islands with that had bird colonies on them had much more elevated bird counts. But we also saw that on the adjacent reefs, they actually had elevated rays and sharks as well. And so that's interesting, and that means that these subsidies are relevant for megafauna, which we typically think move around more. And we also had a look at the foliage cover, which you know, potentially could be a confounding factor, but we didn't see that much difference between the 2 groups of islands. So this is some of the work we did in Belize. This is a typical transect. So this is about 10 kilometers one way, 10 kilometers back. That takes about 30 minutes on the drone. So these things fly quite fast, 60 kilometers an hour. You know, obviously very sensitive to weather, so you need to be mindful of that. But typically we suspect we can fly up to an hour and a half. Again, you want to be mindful of the wind. You know, you want to fly against the wind when you're heading out, and then let the wind help you to come back. Otherwise, you could be in an awkward position where you have to land far away from your control station. Yeah, so over the space of 2 weeks, we did 24 flights, and we've had several students working on this, over 50,000 images, in total of over 200 kilometers of aerial transects. We've been working to develop random encounter models, and this models both the megafauna that we saw and the drone as gas particles, basically. So you can apply quite reasonably simple mathematics to model the probability of an encounter or a detection, and that allows you to generate densities. And these are some of the animals that we detected, so turtles, manatees, and sharks and rays. We also did some work looking at habitat classification, and this, you know, again allows us to identify priorities and vulnerable habitats. And we looked at how different altitudes were going to affect the accuracy of some of these algorithms we're doing to recognize and categorize different habitats. Perhaps not surprisingly, we saw that lower altitudes were more accurate. However, the literature is actually a little bit complicated on the matter, so it wasn't as clear-cut as we initially thought. In terms of the work we're going to do, we've just come back from Lake Victoria, where a recent directive a couple of months ago precluded us from being able to fly. So this is the sort of challenges we're having. Is that things are changing so fast we're not able to actually to get the necessarily permits that we want to. But I suspect we're just in a particular turbulent time on this subject, and it's going to probably taper off a little bit. We've now got a calibration that works whilst we're on a moving vessel, so that was a bit of a concern initially, but we now solved that. We've also been working on a dynamic homing position. So we've developed some code that allows the drone to take into account that the control station may be moving, say if you're on an actual boat. So you can launch the drone, relocate the patrol boat, and then the drone can come back to the control station. But the reason why this is important is that if the drone ever loses telemetry link, what happens is that it goes into RTL, or return to landing. And if it hasn't updated your control station whilst you've been relocating, it's going to go back to where you launched it from, which again could be quite awkward. Longer term, we're going to be working on developing machine learning algorithms to enable on-the-fly detections. So this is quite advanced in a lot of terrestrial animals, and that's simply because it's easier to get footage that you can run these algorithms on. So we're going to have to do, build up quite a lot of images, before we can start doing this. And finally, we want to integrate the drone as part of patrol-based monitoring protocols. So I'll talk to you a little bit about what I mean about that, because it might be a little bit abstract. ZSL is part of a smart conservation tool network, and SMART is basically an app that rangers and patrol and fishery officers use during their random patrols. And the strength of this is that it allows you, without being in the field, to collect data on the movement of things like megafauna, and obviously whether your patrol efforts are allocated in the right place. And it's currently used globally, and it's sustained by 9 conservation agencies. So it's very popular. And it does encourage log keeping. So it's the sort of thing, it encourages consistent log keeping between rangers. And we train the rangers up in how to use this. So we've analyzed the images from where the megafauna was, and then mapped it against what we saw from the drones. So this is the patrol-based detections they've done. And we've looked at how the community from the patrols map onto what we see on the drones. So there's some overlap, so you can see where you can reliably use the patrol data versus the drones, and you can see obviously there's clear biases in some animals which are detected predominantly by the rangers. And the other thing is making sure that your patrol routes are adequately allocated according to the fishing pressure. So this is from Turneth again. If you can imagine, you've been patrolling an area, you get nice information of where the fishers are going, and then you want to see if you should change your patrol routines. And in an ideal world, you want the surface of the patrol effort, to map perfectly onto the fishing effort. So when we analyzed this, we saw that there was quite a lot of a mismatch. So we can now go back to the rangers and say, have you thought about working some more here where there appears to be more fishing than you're able to actually record as part of your work? So the sort of take-home messages is that MPAs are really only as good as their enforcement and how much the people are complying with them. And the underlying drivers for why people try and fish illegally are very complex. And this should motivate us, given the cost of doing field work in these remote places, to maximize any kind of surveillance technology that's being applied in these contexts. And patrol-based monitoring is kind of part of that movement. And it does, but it does require some further research to identify limitation and biases of those data sources. I want to finish off by acknowledging all the work by students who've been involved in this. We have Claire, again, who's doing the socioeconomic work in Sri Lanka. Melissa, second from the top, who's currently going out, to Bayot again in a couple of months to do further trials and to test this dynamic home positioning. And obviously all the many institutions and funders who are facilitating us along with our collaborators. Thanks very much.